I'm Martin. I'm CEO and co-founder of Example 42. I'm doing Puppet since 2007, I suppose. Yeah, quite for some time. Some people name me a dinosaur in the Puppet community. And I usually don't like to give technical talks, because when I give technical talks, they will become boring sooner or later. Usually sooner, not later. What I'm going always to do is some kind of war stories. So we could do consulting for companies. And especially when it comes to modern technology. So we have changes every time, a couple of years, things dramatically change and people want to do something different. And now we have this container thingy on the way, and we usually see at customers either a lack of understanding or a huge amount of misunderstanding. And so this is now a summary what we've seen at several customers. And the reason which gave me the influence to doing this talk was I've been at the customer, someone from Ops team showed up and saying, oh, we have an invitation for developers. They want to talk about something new. I said, yes, this is what we call DevOps. So do talk in front prior you do something. I said, yeah, they want to have containers in production. But that's fine, that's totally super. You can concentrate on something like storage, performance, networking, and let the developers do all the other hard things like staging containers, deploying containers. That's totally fine. Yeah, but we don't know how to deal with containers. So can you please join in this meeting, because we want to have someone who can give us some support. I said, yes, okay, no problem. And by the way, have you looked at the invitation whether security is also invited to that meeting? And I said, no, security is not invited, please bring in security. So we had the meeting. Developers were not really happy that they're now having more people attending that meeting because they came up with several ideas on how should we inside the company now deal with containers. And they followed the principle they had in the past. They said, Ops is preparing virtual machines for us, so they should now prepare the containers. Ops is responsible for the security, so they should be responsible for container security. Ops stages the content, Ops deploys the content, so everything as is, so no change in responsibilities, we just change what we have underneath. Yeah, it was quite shocking for everybody when we heard this. I said we did quite some analysis on how to do that, and luckily we had the security person jumping in and saying the first thing is now Ops can't check security for containers. The container should only have what is inside the container, what is needed, and not any additional tools for managing a container. That's an anti-pattern. And yeah, the last sentence on the slide is definitely something I had to rewrite to be compliant with the code of conduct here, because the original wording has been much more harsh and offending, and so I made it a little bit more suitable for a Puppetize live event, yes. After that meeting, I somehow recognized that there is something missing. There's something missing. There was always something in the air. It was a sound that you heard every time you entered the department. And it was missing somehow. But then it rose up again, and you heard people saying something like, Docker, 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 Docker. I somehow like little animals walking around, so really interesting. So yeah, so everybody is talking about Docker. Most people don't mean Docker by itself, they mean containers, but it's fine, name them Docker, it's the package format, that's totally okay. And around these containers, some myths have come up. So myths like, we don't need configuration management anymore. Nowhere. It's just no longer needed. We just deploy a container. We just throw it out somewhere and sticking there, and we call it the Siemens Lufthaken, so the Siemens air hook. So it's just there and it's working perfectly. It's so much easier to deploy and run everything. It's so much easier to get insights into things. It's so much, everything's totally easier. See, it's on my laptop. You see, it's on my laptop. It's running the whole application. Okay, how do we get that laptop into the data center now? That's the difficult thing we're asking us. And there's even more. There's even more. They say, containers, it's a self-healing platform. Wow. Artificial intelligence or something like that. There's the next thing where they say, you don't have to deal with security. It's built inside the container. It's everything is secure per definition. Interesting. Okay. No connectivity from the outside? Yes, for sure, connectivity from the outside. Then it's not secure by default. Okay. So we don't need logging because it's self-healing. So where do we need logs for? For analyzing when something is broken. But if the system heals itself, then nothing is broken. Then everything is working and running perfectly. We can go serverless. Wow. That's the Siemens air hook. Great. So you don't need CPU, you don't need memory, you need, no, we don't need, at least we don't have to maintain it in the data center. Okay, we don't need hardware anymore. Okay, so please, bear in mind, a container is something where the BSD people will tell you, we have this since ages. It's called jail. It's a change root. We have it running. It's just a packaging format. And within the package, you have something like version control commits that describe the changes from one layer to the next layer. And yes, containers need infrastructure to run on. Think about persistent storage for this moment. And when you see it in another way, you say, you get something like a container. And see this container like being a binary. It's a binary object that you just spin up on multiple machines. Wait, deploying a binary to a system, maybe configuring it, and afterwards ensuring that something is running. I heard people writing manifests, I suppose they call that. So it's something we already have a solution for. So it's already there. We have something. We have Puppet at hand. Puppet helps us deploying software, managing services. So why don't, and was it that they're saying? We don't need configuration management anymore. Okay. Is there something else inside this artificial intelligence self-healing process that does this by themselves? And why are people so eagerly with Docker? What's interesting on Docker? They start, because it's so easy. Well, you see, you just download it from the internet, you install it on your laptop, and you just run Docker pull, Docker run, and everything's fine. Wow, have you checked with security regarding an installation on a production server with curl -k out of the wild internet, piping it into sudo bash? Maybe that's not the right way to deploy software. Yeah, but it's working. Have you seen? I followed the tutorial. And I have my Drupal stack working now locally. That's so cool and great. And what is if Docker-D goes down? The self-healing process. Okay. What's the problem for the ops people? When it comes to containers and container management, ops people are confronted with a huge set of new things that must be done. So they see something like this is well, it seems to be a part of a dinosaur. At least it touches like a dinosaur, it smells like a dinosaur, it's even that old as a dinosaur. So, yeah, but how do you, usually we say in Germany, how do you eat an elephant? Well, you cut it into small pieces. Cut it into small pieces that are manageable. Who has flown in with an airplane? Quite a couple of people. So an airplane is a super complex thing where multiple things must work together. And having the possibility of having a plane in service for 20, 30 years is only possible because from the beginning it was built for maintenance and split down into simple, single things that you can manage and maybe even separately. So get some more details on historic impact. So why are we, not why are we having containers, but what is that we should know about containers compared to the past? So I try to draw a graph. I'm not good at graphing, so please excuse me. On the lower level, we have the timeline. On the left side, from your side, we have the past. On the right side, we have present or near present future or something like that. In the past, we had mainframes. So we hadn't had that much mainframes. Maybe you had one or even two, maybe, for redundancy reasons. When from mainframes, we moved on to personal computers. So the people were no longer logging in via terminal, but they had now their PC next to them, personal computer. Yeah, we had more of these. So 400 users, one mainframe, now we have 400 PCs. The next thing where people come up with, let's use the hardware resources more efficient. So let's not just stack components, but place them into virtual machines. Let's do virtualization. So you even had plenty more. Please consider the left-hand scale, which going to the top, to be logarithmic and not linear. And on the right-hand side, we have the containers. And at some customers, we implemented a Docker-D without telling everybody. So we talked with security whether everything is fine. And developer learned, wow, we have now Docker-D running in CI, and now they have exploding containers running around. So expect that to be logarithmic scale. On the other hand, let's see how is the uptime of these systems going over time. A mainframe usually is, well, it's just running. You don't do maintenance on mainframes, they are running. When we have personal computers, we already learn some kind of downtime. For example, kernel upgrades, they need a reboot. During the reboot, they have a downtime. I don't know whether it's a fun or a sad movie, but there was an advertisement movie from a Hamburg-based company. They were moving their location, and they took their BSD gateway with a power supply and a GSM dongle connected to it and moved it in public transportation. So saying, we're a cool company. And this is a very, very, we have to take care on that system. It has 850 days of uptime. Ask someone from security what he thinks about 850 uptimes. Okay, so then we have moved on to virtual machines. And virtual machines is something, oh, we can move them around the data center from that cluster to that cluster. Yeah, but in between they're unavailable, so they have lower downtime. And now we come to containers, and I see people saying, oh, we can place everything in the container. Let's put the repository server inside a container. How long should this container run? As long as we need it. How long do you usually need a repository system? Well, around about 5 to 8 years approximately. Well, that's not what containers are meant for. Containers are meant for short-running instances. The next thing, which isn't even on the slide, is something you can see as a function as a service. So this is not even running permanently. Per request, you get something started up. When the request is answered, it gets teared down again. So you can't talk of uptimes anymore. That's just seconds. So yeah. The biggest problem we have with that is that the staff does not align with the numbers of systems we have to manage. So we have increased number of systems, we have decreased uptime, so increasing downtime, which means more work due to more systems and even more work due to lower uptime. Yeah, okay, how do we deal with that? Well, there's only one way to go for. Go for 100% automation. You can't, when you start working with containers, stop doing anything manually. It's impossible. You can't handle that. 25,000 containers, changing on how many builds do you do per day? Oh, we are super agile. We do 5 deployments per day for at least this application. So it's permanently, it feels like you have a permanent defibrillator on your platform, and things are always changing. People start to use working with the 80-20 pattern. They say, you see, this is a difficult project, and we only have a limited amount of time. And usually you say you can do 80% of the things that you must do in 20% of the time. So stop when you have done the 80% and stop doing the last remaining 20%. Where does this lead to? The 80-20% is still valid, the pattern itself, it's still valid, it's still there. It just means it changes. You need 80% of your time doing the 20% not automated. So the time is now the most important thing that you have to take care about. That's the reason why we explain automate everything you're having in your platform. Know what you have and start automating it, at least, or continue automating it if you haven't started, continue if you already have started. So what's the problem with ops people and containers? Well, we don't know how to operate containers. We heard about weird things like Kubernetes has beer inside. Oh, I'm stopping you from having beer. Yes, I know. So there's multiple things around, and what is it that we should look for first? I can recommend the first thing is reading. Stop directly doing some weird thing you find on the internet, curling, piping, bashing things on your production systems. Stop doing that. Start reading first. Consider a container to be a short-running instances. There's a website that has collected best practices around containers that even deals with the coding itself. So every commit results in a CI, in a build and a CI. When the CI is successful, you have a deployment. And if the deployment fails, you have a check hopefully after deployment, then you revert the deployment again. Take care on persistent data. When you shut down a container, the container is gone completely. Everything you changed manually inside the container afterwards, manually. What a weird word. I thought we want to automate everything. Yeah, but how do I start automating now? Now I've understood the concept of containers. How do I start automating this huge thing I have around there? Well, the first thing is manage the container runtime engine. So, for example, you want to play with Docker, you have learned about Docker, so use the Puppet Docker module to configure your Docker daemon. So, where's the registry that you want to use what is the network setting that you want to have inside, which file system you want to use underneath. Is Discovery yet able to connect to Dockerd? I haven't seen it yet so far. Hopefully it will come, but that you can use Puppet Discovery also on Docker running systems that have a container runtime engine, so that you get the insight on what is it that I'm running. You want to always know what you have in your platform. Because when you know what is happening in your platform, Jonathan had this on one of his slides, then you know about security impact of your platform. As you mentioned, hackers don't care about your documentation. They look what you have in there. We started using the Dockerd first in CI/CD pipelining by saying we had the presentation, the best 4 topics you do when it comes to module development. It was a great talk, by the way. I was just missing one thing, the acceptance testing. I know it's hard to do it in a way that everybody can use it in the same pattern. But we used it for, how do you call it? It's not unit testing, it's acceptance testing our Puppet code. So we spin up a container, we apply the Puppet code inside, and afterwards we check, is this container looking as expected? And either way of the result, we throw away the container. So it's a short-living instance only. So we have enabled it in the build process. We have some departments that use Docker daemons for having dashboards, and they usually change their dashboard, maybe from sprint to sprint. So that's okay, having a container running a dashboard. That's totally fine. And have you seen Puppetware, the repository on GitHub? Puppet as a container. You have the Puppet server standalone, you can have a Puppet server and a Puppet DB separate to it, so all of your Puppet infrastructure is there and ready to get deployed as containers. So you want to test out whether your code is working on Puppet 6? What is that we have to do? We have to do this, first we have to bootstrap a puppet master. So like Münchhausen, who was somewhere in the desert in the sand, he pulled himself out with his own hair. We do something similar. No, you don't have to. You don't have to. Have a CI pipeline and have just a Puppet server set up, spinning up automatically and check that your code is working on the new version of the Puppet server. That's totally fine. So you even spare more time by having containers used by ops, not by applications, but for ops things. Okay, once we have learned about, okay, we have that single node over there with a runtime engine, what's the next thing that we have? Okay, now we want to have it high available so that we have multiple things, maybe living a little bit longer than just our testing containers. Okay, we have to deal with container orchestration in this point. Okay, what is now container orchestration? We heard about orchestration from Puppet already. They already mentioned orchestration. Yeah, the way how we deploy Puppet agent runs in our platform. Similar. Similar. You will have multiple nodes that together build the service. Because you want single hardware, you want to do maintenance. But we thought we were going cloud native serverless. Let's wait a short moment. First, you are still in your own data center. You want to have an orchestration. The next thing you want to look for is, how do I get traffic to my containers? Please don't look at the IP tables rule set. The TCP package will usually somehow get somehow wibbled around for a couple of times until they reach somehow their final destination, the container they should have access to. Consider playing with maintenance. So try to break the things as soon as possible, because then you learn how it is working and you learn what you should not do with it. Even sometimes it's more important than to know what to do, to know what not to do. Think about an application stack, and then think about the solution you would like to have. There's the Puppet Labs Kubernetes module, and Puppet Labs also does something for Docker Enterprise, the universal control plane or the Docker data center. So the Docker data center just has the trusted registry next to it. Of course, you can use pipelines also as a registry for containers. This is what it was built for. So consider choosing your correct application stack. Think about the difference between self-hosted or managed. So do we really want to deploy a Kubernetes cluster and manage that thing completely by ourselves, or are we heading for cloud vendors anyway? So every cloud vendor will give you a hosted container runtime solution for multiple systems. Or do you want to build it by yourself? Maybe Kubernetes is even far too much for you. Maybe Docker Swarm is already completely sufficient. Docker Swarm is something you can configure with the Puppet Labs Docker module, so it's already there. You just have to use it. Well, okay, now everything is in containers. We have PuppetDB in containers, we have the Puppet server in containers, everything is containers. So we only manage now from a container, we manage the hosts underneath that run inside a container runtime engine. Sounds again like the Munchausen problem, but yeah, seems to be something. Okay, but what about you don't have persistent data? No databases, no storage around, it's just floating around somewhere? You still have something where you have data. You can't move everything into containers. Consider, for example, that you have applications where the software vendor will tell you it must run on /10. Whoa, /10 is out of support for ages. Yeah, but we are only supporting /10. Okay, yeah, of course you can spin up a /10 container, but maybe they will tell you, no, it must run on physical hardware, otherwise you won't have support, because we don't know containers, we don't know what you do inside. So something like legacy or enterprise-y applications, especially the old school applications. Consider something different when it comes to monitoring. So people are using, who's using Isinga or Nagios here? Almost no, just a couple of people, okay. This is meant for static platforms, so you know upfront these are the systems that I'm having. Okay, maybe you are using PuppetDB and exported resources to identify new systems immediately also on your monitoring solution. But as I mentioned, you have something that is constantly changing underneath when dealing with containers. So please check a solution for monitoring that adopts to that pattern. Don't think about individual services anymore. So you just want to be sure I want to have 10 of these instances of at least 5 different cluster nodes. That's the important thing you want to have, that the service itself is working. Get monitoring tools and, of course, configure them and install them by using Puppet and Puppet modules. There's, for example, for Prometheus, there's a Vox Populi module that allows you to install Prometheus servers and even the agent side. Okay, you have a container, maybe it's already built inside. Serverless. What's the next one? Opsless. Oh yeah, great. Yeah, that's really funny. So yeah, the Siemens air hook, it's there. Yeah, so serverless, opsless, useless, brainless, painless. Sorry. Serverless doesn't mean you have any hardware anymore. It just means it's someone else's hardware. Like you see the stickers where you said cloud, it's just someone else's computer. The same is for serverless. It's just someone else's hardware. You still need CPU. You still need memory. You still need storage. Well, opsless. Okay, so who's taking care on that thing running over there, what you have at this serverless thingy? Yeah, it's, well, developers take care on that. Oh, and they know how to set up VPN tunnels, the networking, and so do you only network engineers? What about your persistent systems with persistent data? Have you thought about these? So opsless doesn't mean you have no ops. It just means that you say it's somehow shifted, that developers also can, yeah, somehow contribute and do part of the ops work. Whenever it comes to moving to the cloud, always consider asking finance whether this is okay for you, whether you're still in a scale where cloud is more cheaper than running it on-site. It has to do with capital expenses versus operational expenses. So that's a shift now from where we say, well, we want to do DevOps, maybe we want to do DevSecOps. But what is it that we do now? We do DevSecFinOps? Yes, for sure. Ask them. They can give you proper details whether running on cloud really is the best from finance perspective. I will slightly be over time. Let's say someone has opened, let's not say Pandora's box, let's say a box first. Someone has opened a box, and out of the box came a container. Wow, usually we place boxes inside containers. Now we have a box inside a container, okay. So someone has opened the box and now we have containers around. And stop blaming around for developers being ugly because they want to have containers. Stop just refusing to deal with containers. Containers are used at even enterprise customers. At least they start thinking about using cloud-native thingies, which is the container part at all. So please stop complaining and start playing around with it. Break it as soon as possible. Have a playground for yourself. Security first. Automate everything. Otherwise, it's not a proof of concept. but just a pile of crap. Because you, yeah, you just did it manually. So doing something manually, can't be a proof for anything because you haven't proven anything. Maybe your knowledge on how to make it manually, yes. Choose the tooling around, get a CI/CD pipeline, whatever you have. And always consider this, it's not really ops should hate containers. It's ops should hate systems where they have no idea that they exist, which are not under their control. And please stop hating containers. Thank you.